Hi guys, I am Divyan from IGCSE on Fingertips. Today we are going to discuss some general questions that are repeatedly asked in your board exams about the direction of current or the direction of the motion of the magnet or the coil or the direction of the north and the south pole. Let's first understand the most basic direction, right? The most basic direction that we understand is if this is the direction of the current, right, and I want to find out what is the direction of magnetic field around it, I use my right hand thumb rule. Let's first write the rule. So it should be right hand thumb rule. What should be the rule? That if thumb shows the direction of current, then the curling of your finger shows the direction of magnetic field around it. So this will be the direction of magnetic field around it. This will be the direction of magnetic field around it. It is a concentric circle, and these are magnetic field lines. As we know, they are closed loops. They are drawn like this. That is the first rule. Now let's understand what else do they ask. So one more thing they generally ask is that let's say this is a coil which is placed between two strong permanent magnets, right? Let's say the coil is A, B, C and D. There are two variations of this question. The first variation says that if there is current, what is the direction of rotation, and if we rotate this, what is the direction of current in this coil. So first let's find out what if there is already current, then what is the direction of rotation. So let's say the direction of current here is from A to B. How is this acting? This is acting like a motor. We have a strong electromagnet, we have a coil, and we want to find what is the motion. Motor, right? If motion is the output, we're looking at a motor. For motor, we use left hand rule, right? R comes once, R comes once. So we use the left hand rule. This is my left hand. So I will align the first finger with the direction of magnetic field. This is so. The second finger with the direction of current. So this is so. And my thumb must align with the direction of the motion. They must remain perpendicular to each other always. You can't change it like this. Okay. They must remain perpendicular always, and these two must align with the directions we already have. Then the third one will give the output. So first direction, second direction, and therefore into the board, right? The direction is into the board. So AB is moving that side. Now let's understand how is CD moving when current is like this, because it is a loop. This should be the direction of current from C to D. Again we will go for left hand. So this is my left hand, right? This is still the direction of the magnetic field, but now this is the direction of the current, and therefore this becomes the direction of the motion. So I can say the AB part of the coil, or the left hand side of the coil, is going inside and the right hand side is coming outside, right? And if somehow this coil was placed on a mechanism which could help it rotate, then this would start rotating, right? It would go like this, right? This is going inside and this is coming outside. So this should be the direction of the motion, right? This should be the direction of motion. So this is one possibility that they can ask. For the same arrangement, they can ask that what is the direction of current if you are moving the armature, the coil, right? So let's say again we have the same construction. As I already told you, that was motor. So if you can guess what this will be, this will be a generator, right? We can generate motion through water, right? Falling water, then it is hydroelectric. If it is through wind, it is windmill. If it is through heating of water, then it is a thermal power plant. It may be a nuclear thermal power plant, it may be a coal thermal power plant, and so on. So let's again understand. Let's say they are moving this coil in the same direction, right? They are moving this in the anti-clockwise direction. So let's say let's say that AB is moved downwards and CD is moved upwards. Let's say if it is north and south, going downwards and going upwards. Okay, so let's take a box. Let's take a small box and let me make you understand. Okay, it's moving like this. Sorry, it's moving like this. Okay, I need to find out what is the direction of current in this and this side of the coil. To understand that, let's use what hand rule? We will use right hand rule, because this is a generator, right? R comes twice. Right hand rule short form has R twice. This is a shortcut to remember what rule to use. So right hand rule, and we are using generator. Right hand, north to south. Align my finger north to south. For AB, the direction of motion is downwards, right? The direction of motion is downwards. Now, something to remember here. The first finger always stays the magnetic field direction. The thumb always stays the direction of motion. And the second finger always stays the direction of the current. No matter if it is a generator or if it is a motor. Magnetic field, motion and current, mutually perpendicular, can change the direction like this or like this, but their mutual direction cannot be changed. So north to south, the direction of the magnetic field, and this is the motion, right? This is going downward, so this is the direction of motion, and therefore the current is from B to A. The current is from B to A. You look at the same logic, you will find that the current goes from D to C when the generator in this position. Generally, they ask us these questions, that what is the direction of current or what is the direction of motion. Now, because we have used different hand rules, it will be evident to understand that in both of these examples, the direction of motion of coil is the same, but the direction of current is opposite, because we had used different hand rule, and which is the logic behind these things. So that's that. Now, there is something interesting they ask. Okay, so they give you a coil. Let's say this is the coil, and it's connected to just a galvanometer. Then they say that a permanent magnet, there is a permanent magnet here north, and this is the south of that magnet. Now they will tell you that this magnet is moving towards the coil or away from the coil. I'll get into it in just a moment. So let's say this is moving towards the coil. What is the magnetic pole of the coil on the right hand side and the left hand side? How would you solve this? Now see, the logic or the principle behind this is Lenz's law. Lenz said that the current produced, the current induced, the voltage induced opposes its own cause. Okay, this is the statement, but what is important to us? It is important for us to understand that this would be the north pole and this would be the south pole of this coil. Why would that be? Because let's assume for just a second that instead of being this north and this south, let's say this is south, let's say this is south and this is north. What would happen? If I just leave this magnet here, the magnet will keep on going from right to left. Now that is a perpetual motion machine, or in other words, I'm not doing any work and I'm still creating electric energy. That is against the law of conservation of energy. So this cannot happen. This cannot be the south pole. It has to be a pole such that I have to continuously apply force, right? So this is the north pole and this is the south pole for that particular reason, right? Because it is north pole, it repels this magnet, and that is why I continuously need to apply a force to move this magnet across the coil, and hence the Lenz's law. Now let us understand what is the direction of current on the right hand side of the coil and left hand side of the coil. So this is the right hand side of the coil and this is the left hand side of the coil. I would draw a north N like this, which would give the direction of the current when I am looking at coil from this side. Okay, I'm looking at coil from this side, the direction of current is anti-clockwise for me. Let's say you're sitting across me and you're looking at current from this side, and hence you're looking at the south pole. The direction of current in south pole is clockwise, which is evident. Let's see, let's rotate this box. Okay, why I made a mistake just 2 topics ago in rotation. So for me, if this is rotating, what direction is it rotating for you? For you, it is rotating clockwise, but for me, this will be rotating anti-clockwise. This is how it happens when you are sitting across or when you are looking from other or opposite directions, right? So I remember that this is north pole because north pole repels. This is the direction of the current inside the north pole. This is there, right? Now they trick you a little bit, okay, not a lot, but they trick you a little bit, and they ask you what would happen if this coil is moving away. If this coil is moving away, then again this coil, right, the temporary magnet coil, must oppose the motion of the permanent magnet, right? Not coil, sorry. Permanent magnet, if it is moving away, the coil must oppose the motion of permanent magnet. That is what we have understood. So when this is north, this becomes the south. So it becomes difficult for me to withdraw from this coil, right? How do they ask this? They don't ask it straight away and like this. Let's see. So they will tell you that this is the coil. Okay, and these type of questions do occur mostly in MCQ. They say that this is the north, this is the south. The magnet is moving through the coil from left to right. This is position 1 of the magnet, and in position 2 the magnet is still moving in the same direction. It is moving from left to right, but this is the direction of the magnet, right? They will ask you that, let's say this is point A. What is the pole of point A in position 1 of the magnet, and what is the pole of point A in position 2 of the magnet? Remembering Lenz's law, I will say that when it is here, the magnet is here in position 1, I find that A must repel the south pole. To repel the south pole, A must become a south pole itself, right? Now, when the magnet is moving away, right, just let me write that in position 1 it is a south pole. Now when the magnet is moving away, this part of the coil here must attract the magnet such that it opposes the motion of the magnet. So this must become south pole, right? If this becomes the south pole, it is attracting the magnet, stopping it from moving away. Hence you have to do some work to make it move away. Hence the law of conservation of energy is applied. So if this is the south pole, this must become the north pole, and therefore in position 2 of the magnet, the coil at A has north pole, right? If this is the south pole, then at position 2 this is the north pole, and this is how they ask you questions. Now there is just one small thing that I just remembered I should have included, like right in the first topic, is what is the direction of the magnetic poles when current is passing through a coil, right? The current is passing through a coil. Let's look from here. If the direction of the current, right, now you can't see 3D, so you don't know if I've coiled it like this or I've coiled it like this. I've coiled it, okay. If you look from here and if you find, looking at the poles of the battery or the cell, if you find the current here is, this is clockwise, right, then you're looking at the south pole. And if the current is obviously clockwise on that side, it should be anti-clockwise on this side, then you're looking at the north pole. But there is even a simpler way of finding this out. If the curling of your finger gives the direction of the current, then your thumb is pointing the north pole, right? So curling of my finger in this situation, this should be the direction of the current, and therefore this becomes the north pole, right? And because this is a electromagnet, it does behave like a magnet and has a closed loop where the magnetic field lines are from, sorry, small mistake, are from north to south outside the magnet and south to north inside the magnet, being a closed loop. I think this is what is there according to directions. If I missed something, let me know in the comment box below. I'll make a new video for it. I hope you enjoyed the video. Thank you for watching. Come back for more videos. Leave your likes and subscribe to our channel. Bye bye.